Hi students, so today we will be learning about limits. I will be starting by giving introduction what limit is, what are the different types of limits we may encounter throughout this learning process. Also, I will be dealing with graphs today, and later on we will be proceeding with algebraic limits. So let us start with the different types of limits we have. Now when I talk about different types of limit, we do have some limit which does not exist. By saying that, I mean I cannot find it. Okay. Now apart from getting a finite limit, that means a limit is a number, finite. In case while finding some limits we encounter any of these forms, and we have a total of 7 forms. These 7 forms is categorized under indeterminate form. So I call this as indeterminate form. If you get an expression after applying limit in any of these 7 forms, the limit will exist. You can proceed further and get a limit. Now when I write infinity by infinity, for instance, it does not mean exactly infinity by infinity. It means that, let me explain to you with an example. For example, I have to find limit of n by n plus 1 as x tends to infinity. So when I apply the limit to the numerator, now I need to replace because it's in n. Yeah. Now when n is tending to infinity, where will this n go? It will also go to infinity. And where will n plus 1 go? It will also go to infinity. Because if I add just 1 to infinity, it is still infinity. So I get a infinity by infinity form. That's what I mean. Tending to. We have to keep in mind the term tending to. It is going towards it. It's not reaching exactly there. In the sense, that's not the value of the function. It is going towards that. Okay? Now, there are two terminologies which people do use interchangeably, that is undefined and indeterminate. These two are two different terms. Undefined means which is not defined, for example 1 by 0. It is undefined in mathematics. Now, I still remember students in class 10th, even now, when we ask them what is tan 90, they write it as infinity, which is not true. It is actually undefined. Okay, it is undefined because you get 1 by 0 because it is sine 90 by cos 90, and then you got as 1 by 0 which is undefined. So this is wrong. Writing infinity as tan 90 is wrong, because if you even draw a graph, let me make you understand. So if you are at pi by 2, and if you remember the graph of tan, it is something like this. See? So when your x is, so when I say tan, when my x is tending towards pi by 2, which is 90 degree, where is the function going? The function is going towards where? It is going towards infinity. But here I am asking you the exact value at pi by 2. Can you see tan pi by 2 value anywhere in this graph? No. So if I want to say what is tan x as x tends to 90, I will say it's infinity, or I can say it does not exist. But when I say what is tan 90, I would say it is undefined. It's not defined in maths. Okay? Now, indeterminate are any of these 7 forms. Also, when I write 0 by infinity, keep in mind this is not exact 0 and this is not exact infinity. I have substituted some limit and then I got as tending to 0, and this is tending to infinity. The same case is over here, but in this case it is exact 0. Now after substituting the limit, if I get one term as exactly 0 multiplied with infinity, then it would be 0. And if I get exact 0 after putting the limits, and here also I am getting exact 0, then it is not defined. Okay, now let's have a better understanding using this graph. This will give you a better picture about the graph. So I'm going to solve few of them, and the rest I would ask you to try it by yourself, and then again I will be writing the answer. Now, what do you mean by x tending to 0 minus? What is this? In simple words, if I want to put it, let me plot 0 here first on the number line. Now, first look at the number which is mentioned here. That is the number you need to reach. Now, this sign talks about from where to reach, from which direction to reach. When I say minus, that means I am reaching from the left towards 0, and that is denoted by this. And when I say I am moving from right hand side towards 0, then I would say 0 plus. Here I would say x tends to 0 minus. I hope you got an understanding on that. Now let's come back. Now when x is tending to 0 minus, so where is my 0? Here. Now I need to come from the left hand side. So when I come from the left hand side and coming towards, very important, towards the point. It is towards the point. When I am coming towards 0, where is the function going? If you observe very carefully, the function is not even defined for x less than 0. It is not defined. What is not defined? Function is not defined. That means what? Here the answer is not defined. Okay? Now let's look over here. When I am coming towards 0 from the right hand side, if you look at the function, okay, so the function is also coming towards minus 1. Look very carefully. When I am moving towards 0, if you take the function value for those points, you will see it is reaching to minus 1. Now let's look at this. I have to go to 1 and I have to move from the left hand side, and if you look, when I move from this, the function value is reaching to 1, right? Okay, I should have written here. And when I am moving from the right hand side towards 0, you have to look at the function value where it is going. It's going towards 2. Now one big mistake that students do is they think that I need to write the value of the function at that point. So they may write 1, not 0, which is wrong. We are not concerned about the value of the function at that point. We need to say where is the curve is going when your function is reaching towards 1 from left or right. Similarly here, if you look very carefully, when x is tending to 2 minus, my function, if you look carefully, it is going towards 3. And here when I am moving, again it is going towards, the curve is moving towards 3. Now let's come to 3. And when I come to 3, I observe that from the left hand side, when I move, the function is taking the value as 2, and here when I am moving from the right hand side, it is taking the value, if you observe the curve, when I am moving towards 3, the function is moving towards 3. Okay, you have to look at the y coordinate, not the x one, for getting the value, getting the limit. Now here when you are moving towards 4 from the right hand side, from the left hand side, let's see first, you can see the value of the function, it is actually constant here, which is 4, and when you move from the right hand side, again the value of the function is still 4. Same. Now here, when x is going, now here there is no positive negative here because it's actually going towards infinity. That means what? When my x keeps on increasing, it keeps on going, where is the function going? For that I need to know the graph. So if you look very carefully, so here is my y is equal to 2, and if you look, this curve is actually going like this. That means what? Where is it tending to? You have to understand where it is tending to. Of course, it's not infinity. Look very carefully. You need to look the y coordinate. So it is reaching to actually 2. Hey, this is 2, right? This is y is equal to 2. This is just keeps on going, tending to 2. It's not gonna touch 2. It is tending to 2. Now what is x tends to 6 minus here? That means, let me erase this. So if you look carefully, on the left hand side, when I am coming towards 6, till this point the value of the function was above. As soon as I come very close, it is in the negative side now, and it is tending to where? It is going to where? See the y coordinate. Correspondingly, it is going to infinity, isn't it? So it is going to infinity, and we write it as also does not exist. Okay. Now, is one important thing that we need to understand, that when can we say the limit exists? The term comes at exist. When can I talk about existence of a limit? I can talk about when the left hand limit should be equal to the right hand limit, and that should be equal to the finite quantity. It should be a finite quantity, right? So my f is missing over here. It should be a finite quantity. Then only I can say the limit exists. So this is my left hand limit. This is my right hand limit. It should be same and it should equal to some finite quantity. Then I can talk about the limit existence at a point. For better understanding, let's come over here. If you look very carefully, you can see that these two have a finite quantity and they are equal. So we can say that limit exists for f of x at x is equal to 2. Similarly, I can say limit exists for x is equal to 4 as well. But for rest, you can see they are finite but they are not equal. So the limit will not exist for other points. Alright. Now let us see what's written over here. You can see I have rewritten the left hand side and the right hand side in some way. Let's understand what does it actually mean. So what I am doing is I am writing limit x tends to a. I am writing x tends to a minus f of x as limit x tends to h tends to 0 f of a minus h. Now why I am writing like this? For this, let's go to the line, number line. Consider this is my a. Also, I would like to tell you that h is greater than 0 always. H is a positive number. H is a positive number. It's greater than 0. Now, what is a minus h? Of course, it's less than a because h is a positive quantity. So you're removing some positive quantity from a, so it will be less than a. Right? Now, tell me one thing. When this h, let us consider a minus 0.1. A minus 0.2, a minus 0.3. Now which one is closer to a? I can say this one is closer to a. That means what? When I take away very less from a, it is going to be very close to a. That's what it is doing. H is tending to 0. That means I am coming very close to a from the left hand side. So it turns out to be my left hand side. Similarly, in the right hand side, we write limit x tends to a plus f of x as limit h tends to 0 f of a plus h. Again here, when very small quantity is added to a, it is going to be very close to a, and I am making sure by putting limit h tends to 0. Okay, so I have just rewritten left hand and right hand limit. This is useful while solving problems. Now the next line, if you look, which is very important, is it's like a condition. When can you say it is equal or not? So you can look that limit, left hand limit is equal to right hand limit is equal to a finite quantity. So here I can say limit exists. From this I can write this statement, this equation I can say. So here there is no sign now. And if this is written anywhere, I can come back and write these two equations as well. Okay, so this is vice versa. Now let's come to another problem over here. Let's do this quickly. It's a true and false question. If you want, you can just pause the video and do it by yourself and then come back and then see the answer. Here I need to find the limit x tends to minus 1. First go to minus 1 and then I am plus. Plus means from the right hand side. So this is right hand limit. So when I am moving towards minus 1 from the right hand side, where is the function going? The function is going towards 1. Yes, it's true. Next, when limit x tends to 2 does not exist, that means what? I need to find left hand limit and right hand limit to conclude. Left hand limit is limit x tends to 2 minus f of x. Let's go to the graph quickly. When I am moving towards 2 from the left hand side, I can see that the graph is moving towards 1. Here I am moving from the right hand side. So I can see the graph is again, this is the graph, it's moving again towards 1. So yes, and that it's finite, so this is false. Next one, limit x tends to 2, f of x is equal to 2. Is this true? No, because just now we got these two expression, and from these two I can write that limit x tends to 2, f of x is actually 1, not 2. So this turns out to be false. Now next one, limit x tends to 1 minus. Now this is my 1 here. I am moving from the left hand side towards 1. Where is the function? The function is going towards 2. So this is true. Next one, limit x tends to 1, f of x. So that means what? So I already got left hand limit at x is equal to 1. I need to find the right hand limit at x is equal to 1. So limit x tends to 1 plus f of x. Let's come here. When I am moving towards 1 from the right hand side, I can see the function is going towards 1. And here it is 2, here it is 1. It is not equal. So left hand limit is not equal to right hand limit. So the limit does not exist. So this is true. Okay. Now from all these, I would like you to take a note, which is very important, that the existence of limit, that is, it exists or does not exist, does not depend on the value of the function at that point. If you look at any problem, the previous graph of this graph, I was never concerned about to find the value of f of 2. Was I bothered about, was I concerned about this? While finding left hand or right hand, I was never concerned. I just took x is equal to 2 and I just was moving right hand side and left hand side. So the limit value does not depend on the function value at that point. Similarly, even if f is defined at x is equal to a, that does not guarantee that the limit will exist. Right? For example, you can look over here. Here, limit x tends to 1, f of x does not exist. But f of 1 is defined, right? F of 1 is what? 1, which exists. So it does not give a guarantee. If the function is defined at that point, it does not give a guarantee that the function value will exist. Okay? And this next one is, limit of a function can be found out only when it is defined in at least one neighborhood. One neighborhood when I talk about, if I take a point, let's say 2, neighborhood means this, near to 2, right and left hand side. The function should be defined in at least one of the neighborhood, or else I cannot go on and find the limit. What does it mean by that? I'm going to give you an example by drawing a graph. So consider, we can draw a graph, any graph for an example. So consider this is how I am defining the graph. Okay, this is my graph. Now when I ask you what is limit x tends to 3, can we find? No, because it is not even defined near its neighborhood. See, there is no graph in this area. So how can you talk about limit? That's what it means. It should be defined in at least one of the neighborhood. So as in homework, I would like to ask you that, can we talk about the limit of the function log x at x is equal to minus 1? If yes, what's the value of that? If no, why not? So let us quickly go through what we learned today. We learned the 7 indeterminate form. We also learned the difference between undefined and indeterminate. Also we recall that tan 90 is not defined. Then we have come across a graph problem for which we found the right hand and left hand limit for both. And then we wrote how to represent left hand and right hand limit, and also in terms of h how to represent. And then we have come to this conclusion, which is vice versa statement, where the limit exists, how we can write in left hand and right hand limit form, and how without plus or minus. Then we have come across a true and false problem. Also, the most important thing that I would like you to remember from this session is that existence of a limit does not depend on the value of the function at that point, and vice versa. Also, for finding a limit, the function should be defined and at least one of the neighborhood of that point, at that point, either right or left. Okay, so I hope you got a better understanding on limit, and if you come across any problem based on graph, you will be able to approach. I will see you in the next session with some interesting problems and a concept based on limits. Thank you for watching my video. Please like and subscribe.